So, Jai Hind friends, in the series of lecture of compiler design, today's topic is symbol table. So, these are the outlines of today's lecture. Firstly, we will discuss about the symbol table, usage of symbol table, information used by the compiler from the symbol table, implementation of the symbol table, and operations on symbol table and storage allocation for the symbol table. These are the outline of today's lecture. So, what is symbol table? A symbol table is an important data structure that is created and maintained by the compiler in order to keep track of the semantics of the variables, and it stores the information about the scope and binding, about the name information, about the instances or various entities such as variable and functions, names, class, objects, etc. inside the program. So, when we will store the information inside a program related to the variable, functions, names, classes, objects, then this information is stored in a data structure, and this data structure is called as a symbol table. So, it is a built-in lexical and syntax analysis phase, and this information is collected by the analysis phase of the compiler and used by the synthesis phase of the compiler to generate the code. So, compiler phases are divided into two parts, analysis phase or synthesis phase, and this symbol table information is collected during the pre phases, that is called as an analysis phase. So, information is collected in analysis phase and used by the synthesis phase, and it is used to achieve the compile time efficiency. This is the main purpose of using the symbol table. So, usage of the symbol table is accessed by all the phases of the compiler and is used to create the information or used to access the information for different phases of the compiler. So, what are the different phases of the compiler? There are basically 6 phases of the compiler, like lexical analysis, syntax analysis, semantic analysis, intermediate code generator, code optimizer, and target code generation. So, here symbol table entity related to the tokens is stored inside the symbol table. In the second phase, it adds the information regarding attribute type, attribute scope, dimension, and line references, etc. inside the symbol table. This third phase uses the available information in the symbol table just to check the semantics or to verify that expression and assignment are semantically correct or not. So, the information stored inside the symbol table is used by the third phase of the compiler. Intermediate code generation phase also refers this information to know about what are the runtime allocated, and this table helps to add temporary variable information that is used inside the intermediate code generation phase. Code optimization use the symbol table for machine dependent optimization, and target code generation phase use this information to identify the information of the identifier that is present inside the symbol table. So, what are the information stored inside the symbol table? We can say that data type and name information, declaring procedure, offset, and if structure or record, then a pointer to the structure table is also stored inside the symbol table. For parameters, we store this information inside the symbol table. Number and type of argument is passed inside the function is also stored in the symbol table, and base address also stored inside the symbol table. So, what are the different ways to implement the symbol table? So, the various ways to implement the symbol table. The 4 common one are list, linked list, binary search tree, and hash table. So these are the 4 data structures that are used to implement the symbol table. So what is list? List is a type. List is the method. Here an array is used to store the name and associated information. Everything inside the symbol table have 2 parameters. One is name and second one is the information. So name and its associated information is stored in the form of array. Then this type of structure is called as a list. A pointer that's name is available is maintained at the end of all the stored records and names and added in order that they arrive. So every name and its associated information as it comes inside the symbol table is maintained through a pointer that's called available. And if you want to search the name and its related information, then we can search from the beginning of the list and till the available pointer, and if not found, then this error use of the undeclared name will be printed. And while inserting the new name, we must ensure that this is not already present inside the table. Otherwise, there will be an error displayed multiple defined name. Linked list. To implement a linked list, to implement a symbol table using the linked list, a link field is added to each record, and searching of name is done in order to pointed by the link of the link field, and the pointer here, the pointer name is first, that is maintained to point the first record inside the symbol table. And the if we'll talk about the efficiency of this linked list, then the insertion is fast as it takes order of 1 complexity, and lookup, if we want to check an item inside the symbol table, then using linked list we will take order of n on an average case for lookup an item inside the symbol table. Hash table is another scheme. Here 2 tables are maintained, hash table and a symbol table, in order to record the data inside the symbol table. Hash table is an array with index range with 0 to table size -1, and these entries are the pointer pointing to the name of the symbol table. And if we want to search an item inside this symbol table, then we can use the hash function that will result the 0 to table size -1 integer values between these integer values. And insertion is very similar to the linked list as it take the complexity order of 1. And lookup, the advantage of this hash table is that lookup is very fast here, and it also take order of 1 complexity. So hash table is a very prominent data structure that can be used for insertion and lookup, that is both are very fast as it takes only order of 1 complexity. Binary search tree is another data structure that can be used for implementing the symbol table. So binary search tree is used and it have 2 link fields, that is left and right child, and all the names are created as a child of the root node and always follows the property of binary search tree. And here insertion and lookup complexity are order of log base 2 n on an average case. So apart from insert or lookup, there are various operations that can be performed on symbol table like allocation, free, lookup and insert, I already told you, and set attribute and get attribute. There are the 6 possible operations that can be performed on a symbol table. So allocation is just to allocate a new new symbol inside the symbol table. Free means we are removing all the entries and we are freeing the symbol table. Looking means we are searching for a name inside the symbol table. Insert means we are inserting something inside the symbol table. And get set attribute means uh, associate an attribute with a given entry, and get an attribute means to get an attribute associated with a given entry inside the symbol table. These are the possible operations with the symbol table. So I've already told about the operations, like we can insert, we can look up the item inside the symbol table. So insertion and lookup, these are the important apart from these 6 operations inside the symbol table. So insert operation are more frequently used because the new keywords, new symbols entry we want to insert inside the symbol table. So insert operation is used to insert the information inside the symbol table, and if inside the source code the attribute for a symbol and its information associated with the symbol is inserted into the symbol table, and insert function take the symbol and its value in the form of argument, like insert this x, and it's the uh, form what is the attribute of this one. And lookup operations execute the lookup function, and it just to search about the symbol inside the symbol table that is present in the symbol. If it is not present, then this will display an error that symbol is not present. So lookup example is lookup the symbol that we want to look, we will put inside the argument. Storage allocation of the symbol table. So we when talk about the storage allocation, there are 3 types of storage allocation that are possible with symbol table: static, stack, and heap based. So in static allocation, names are bound with the storage locations. If memory is created at compile time, then the memory will be created at the static area only once. So this is the disadvantage of the symbol this static allocation, that we just create the static memory to the whole symbol table. That sometimes may be not used. Static allocation support the dynamic data structure. That means memory is created only at compile time and delocated after the program completion. And the drawback with static storage allocation is that the size and position of the data object should be known at compile time. And the drawback is of this scheme is that restriction of the recursion procedure. So dynamic the problem can be solved with the another type of storage allocation, that is stack based or heap based. So what is stack based? In static allocation, storage is organized as a stack. In activation, an activation record that is corresponding to the procedure can be pushed into the stack when activation begins, and when it is pop out when activation ends. Activation record contain the locals so that they are bound to fresh storage in each activation record, and the value of locals is deleted when activation of a procedure ends. So it works on the basis of last in first out policy, and this activation supports the recursion process that was not possible with the static allocation. Another type of storage allocation is the heap based allocation. Heap is the most flexible allocation scheme, and allocation and delocation of memory can be done at any time. In static allocation, generally it is done at the beginning of the compilation, but it can be done at any time and at any place depending upon the user requirement. So heap allocation is used to allocate memory to the variables dynamically, and when the variables are no more used, then it can be claimed back. Heap storage allocation supports the recursion process as well. That was not possible with the static allocation. So that's all about the today's lecture. Thank you.